V-22 is a joint-service, multi-mission aircraft with vertical takeoff and landing VTOL capability. It performs VTOL missions as effectively as a conventional helicopter, while also having the long-range cruise abilities of a twin turboprop aircraft. The Osprey is a tiltrotor aircraft with a 38-foot rotor system and engine transmission STOL mounted on each wingtip. It can operate as a helicopter when taking off and landing vertically. Once airborne, the nacelles rotate forward 90 degrees for horizontal flight, converting the V-22 to a high-speed, fuel-efficient turboprop airplane. The wing rotates for compact storage aboard ship. The Osprey is the world's first production tiltrotor aircraft with one 3-bladed proprotor, turboprop engine, and transmission STOL mounted on each wingtip. It is classified as a powered lift aircraft by the Federal Aviation Administration. For takeoff and landing, it typically operates as a helicopter with the nacelles vertical and rotors horizontal. Once airborne, the nacelles rotate forward 90 degrees in as little as 12 seconds for horizontal flight, converting the V-22 to a more fuel-efficient, higher-speed turboprop aircraft. STOL rolling takeoff and landing capability is achieved by having the nacelles tilted forward up to 45 degrees. Other orientations are possible. Pilots describe the V-22 in airplane mode as comparable to the C-130 in feel and speed. It has a ferry range of over 2,100 mi. Its operational range is 1,100 mi. Composite materials make up 43% of the airframe, and the proprotor blades also use composites. For storage, the V-22's rotors fold in 90 seconds, and its wing rotates to align, front to back, with the fuselage. Because of the requirement for folding rotors, their 38-foot 11.6 meters diameter is 5 feet 1.5 meters less than would be optimal for an aircraft of this size to conduct vertical takeoff. The V-22 has triple redundant flight control systems. These have computerized damage control to automatically isolate damaged areas. With the nacelles pointing straight up in conversion mode at 90 degrees, the flight computers command it to fly like a helicopter. Cyclic force is being applied to a conventional swash plate at the rotor hub. New USNC V-22 pilots learn to fly helicopter and multi-engine fixed-wing aircraft before the tiltrotor. Some V-22 pilots believe that former fixed-wing pilots may be preferable over helicopter users, as they are not trained to constantly adjust the controls in hover. The V-22 can be armed with one 7.62 x-51M NATO 308 in caliber, M240 machine gun or 50 in caliber 12.7 millimeters, M2 machine gun on the rear loading ramp, a 12.7 millimeters 50 in GAU-19 3-barrel Gatling gun mounted below the nose was studied. BAE Systems developed a belly-mounted, remotely operated gun turret system, the Interim Defense Weapon System. It is remotely operated by a gunner, resulting in high disk loading. Most missions use fixed-wing flight 75% or more of the time, reducing wear and tear and operational costs. This fixed-wing flight is higher than typical helicopter missions, allowing longer range line-of-sight communications for improved command and control. The V-22 has a maximum rotor downwash speed of over 80 knots, 92 miles per hour, 150 kilometers at, more than the 64-knot, 74 miles per hour, 119 kilometers at lower limit of a hurricane. The rotor wash usually prevents the starboard door's usage in hover. The rear ramp is used for rappelling and hoisting instead. The V-22 is equipped with a glass cockpit, which incorporates 4 multifunction displays (MFDs) compatible with night vision goggles, and 1 shared central display unit to display various images including digimaps, imagery from the turreted forward-looking infrared system primary flight instruments, navigation TACAN, VOR, ILS, GPS, INS, and system status. The flight director panel of the cockpit management system allows for fully coupled functions that take the aircraft from forward flight into a 50 feet. 15 meters hover with no pilot interaction other than programming the system. The fuselage is not pressurized, and personnel must wear on-board oxygen masks above 10,000 feet. The V-22 has triple redundant flight control systems. These have computerized damage control to automatically isolate damaged areas. With the nacelles pointing straight up in conversion mode at 90 degrees, the flight computers command it to fly like a helicopter. Cyclic forces being applied to a conventional swash plate at the rotor hub. With the nacelles in airplane mode, the flaperons, rudder, and elevator fly similar to an airplane. This is a gradual transition, occurring over the nacelles' rotation range. The lower the nacelles, the greater effect of the airplane mode control surfaces. Targets are acquired via a separate pod using color television and forward-looking infrared imagery. It found limited use because of its 800 pounds, 360 kilograms weight, and restrictive rules of engagement. There were 32 IDWS available to the USMC. V-22s often flew without it as the added weight reduced cargo capacity. The V-22's speed allows it to outrun conventional support helicopters. Thus, a self-defense capability was required on long-range independent operations. The infrared gun camera proved useful for reconnaissance and surveillance. Other weapons were studied to provide all-quadrant fire, including nose guns, door guns, and non-lethal countermeasures to work with the current ramp, mounted machine gun, and the IDWS. The high-speed version of the hose drogue refueling system can be deployed at 185 knots, 213 miles per hour, 343 kilometers and function at up to 250 knots, 290 miles per hour, 460 kilometers. A mix of tanks and a roll-on, roll-off bladder house up to 12,000 pounds, 5,400 kilograms of fuel. Many USMC ground vehicles can run on aviation fuel. A refueling V-22 could service these. It incorporates an extended range fuel system for an 2,130 kilometers unrefueled range, a high-frequency radio for over-the-horizon communications, and a public address system to communicate with passengers. The range increase comes from extra fuel bladders through larger external sponsons, the only external difference from other variants. Its primary mission is long-range logistics. Other conceivable missions include personnel recovery and special warfare. This versatile, self-deployable aircraft offers increased speed and range over other rotary wing aircraft, enabling Air Force Special Operations Command aircrews to execute long-range special operations missions. The V-22 stood out as the most capable aircraft to support over a long distance by traveling more than 1,100 miles and providing immediate support in the disaster area. The Ospreys helped evacuate 1,200 people and delivered 20 tons of critical supplies to areas where planes and helicopters couldn't reach alone. Naval Air Systems Command awarded Bell Boeing a contract to deliver and install kits which include new nacelle wiring, conversion area harnesses, and structural enhancements to improve the reliability and maintainability of CV-22 nacelles. Nacelles house the Osprey's engine and critical wiring components, and approximately 60% of maintenance man-hours are spent in the nacelles. For more than 30 years, the Osprey has advanced single aircraft capabilities and radically enhanced mission capabilities. As the needs of the military continue to evolve to the modern world, so too does the Osprey. Benefiting from a foundation of versatility, the V-22 remains ideally situated to respond with speed and agility in a way that only a tiltrotor can.